Hey everyone, hope things are still going well at home. Just wanted to take a moment to continue on our series of sort of working through the packet in case people are feeling stuck. So today's topic is solving by elimination. So we already did solving by substitution, and you're going to find there's some similarities in this. But instead of just adding and subtracting variables, it turns out we can actually add and subtract entire equations. To give you guys an idea of where this heads eventually in the future, when you get to college level math classes, if you decide to take them, we actually are able to do this with a great number of equations and a great number of variables. So let's say you wanted to model something complex like the spread of a major virus. Well, that's a lot of variables. How much are people washing their hands? How much are they actually practicing the social distancing we're all talking about? So if you have all of these to keep track of, it can be really complicated, but there are actually ways. So we actually end up putting them in these things called matrices, which look like these brackets on the end and are otherwise, kind of complicated. And we'll get more to those in Algebra 2 rather than this class, but they are a useful thing to think about. And it's nice to know where this is headed, that we actually use this method all the way through up to the most complicated systems. So I'm going to shrink my face, which I'm sure you'll mind. And here's our first story problem. So this is the first problem in the packet. The sum of two numbers is -22. The difference of the two numbers is 8. What are the two numbers? So to solve this, I'm going to have to move my face a little again. There we go. We're going to make some let statements. And these are going to be pretty boring let statements for this one, so don't worry. Let x equal the first number. Okay? The first number. And y equal the second number. We don't actually care which one's which. It's just useful to have a different way of talking about them. So then my system. So the first equation I'm looking at is the sum of two numbers is -22. So x plus y equals -22. The difference, the sum, by the way, is a plus word. The difference is a subtraction word, of the two numbers is 8. X minus y equals 8. You're probably already noticing that y is probably not going to be a positive number. So in this box, I want you to rewrite the system so the terms are aligned. In this case, they actually already are. We have the x, the y, and the constants lined up perfectly. And you always want to set them up this way. This helps you not make mistakes. So we can actually skip this section this time. Determine which variable you will eliminate. So what we're looking for to decide variables that we can eliminate is which one we can get to be an additive inverse. As a quick review, additive inverse means that they add up to 0. So x and negative x, 5y and negative 5y, anything like that where they're going to add to 0. So in this case, you can see we have y and negative y, so I'm going to choose to eliminate y. It will certainly be easier than multiplying everything. So for this next step, I wanted to say, like, if we were doing x, let's say I decided to choose x here, I would have to multiply one of these all the way through by a negative so that one of these would be negative x. In this case, I don't have to do this. We'll see an example where we do in the next example. Combine the equations and solve for the other variable. Now, what I mean by that is we're actually going to add the equations exactly as you would normally. If you were able to add them in one equation, we're just going to add them up vertically in the same way you actually kind of learned to add when you were younger. We line everything up, and that way place value takes care of things. In this case, we're going to line everything up so that the variables take care of themselves a little. So x plus x is 2x. Y plus negative y is 0. So we won't write that because mathematicians are lazy. -22 and 8 is -14. So now I can solve for, now I have one variable and one equation, and I can solve for the other variable. Wait. What does that mean? Well, hang on. So now if I divide both sides by 2, I get x equals -7. So there's that first variable. Now below here, substitute to solve for the eliminated variable. So I'm going to go back to this up here, the x plus y equals -22, and sub in. So I'm going to rewrite that just so we can see it all on one screen. I realize that this is part of the issues of trying to use it like this. X plus y equals -22, and now I'm going to sub in this x equals -7. So you can see it here, -7 plus y equals -22. Whoops. And now I'm going to add 7 to both sides so that I can keep going. I shouldn't have closed the text box. If I add 7 to both sides, I get y equals, yeah, negative 15. So what's my answer? Yeah. So what's my answer? If I add, my answer is going to be the x value from up here and my y value from here. And I would write that as an ordered pair, negative 7, negative 15. Ta-da! First one done. Hey, this one is actually not in your packet, so I wanted to give you an entirely different example. So you want 6 birds. Chickens take 4 square feet and ducks take 6 square feet. You have 30 square feet in your coop. How many of each type should you get? So here we go. Ready? Let C equal the number of chickens. Just in general, your variables are always going to be about the things you're asking about. And D is obviously the number of ducks. So what does our system look like? Well, we know we need 6 birds. So we're going to have C plus D equal to 6. We also know how much space they take. So the chickens will take 4 times the number of chickens, or 4C, and the ducks will take 6 times the number D, the number of ducks. And we know that's going to come out to 30. Now, we already have these aligned if I add some spaces in here, so we actually don't have much to do in the next step. Now determine which variable we're going to eliminate. And in this case, I don't know that it actually matters, so I'm going to choose C because I can. Doesn't really matter. Sometimes there's an obvious one, sometimes there isn't. Usually if there's one that has a 1 out in front and the other doesn't, I'll always pick the one with the 1. That usually makes my life easier. Multiply if necessary to make elimination possible. So here's an example where we actually need to do that. So here's what I'm going to say. I'm going to multiply this entire first equation by negative 4. So I'm going to write it C plus D equals 6, and that's going to turn into this. Negative 4C minus 4D equals negative 6 times 6. I'm sorry, 6 times 4 is negative 24. That's where that almost went wrong. So now that I've done that, I'm actually going to rewrite the 2 equations on top of each other. Hey, look, copy paste. And then I have this, 4C plus 6D equals 30. So now they're lined back up and you can kind of see it. Now, why did I multiply that first one? Because now I have negative 4C and positive 4C over each other, and that's going to help me. So now in this next one, oops, there we go. When I add those 2 equations, what do I get? 4C and negative 4C eliminate each other. That's why we call this the method of elimination. So I don't have to write anything. 6D minus 4D is 2D, and 30 minus 24 is 6. So what's D? Well, if we divide both sides, we get D equals 3 ducks. Now, in this case, solving for the other one is not so hard because we actually have that C plus D equals 6. So as I write that back in, just so you can see it up close, C plus D equals 6. If D is 3, C plus 3 equals 6. So subtract 3 from both sides and I get C equals 3 as well. So what's my solution? And on this one, I could write it as a point, but I might also write it this way. I might actually write it out in English. 3 chickens, 3 ducks. Ta-da! There's how you solve by elimination. If you guys have any questions, please feel free to call me or send me an email or text. Hope you guys are doing really well. Stay safe. I can't wait to see you all again soon.